Continuation of swing equation. Once again, welcome back. So, rotor dynamic and the swing equation, right? So, swing equation, where exactly we'll get it? In the rotor, right? Because rotor is a rotating part of the machine and stator is a stationary part of the machine, and rotor is having a rotating magnetic field in the synchronous generator or synchronous motor. Keep it in your mind. So, rotor is having a field winding and the stator is having a stator armature conductor, but stationary, right. So, when the rotor start rotating, so there is a electrical output as well as mechanical output. So, already I told you torque is nothing but a twisting force, right. So, at the time of starting, if suppose power failure occurs suddenly, so the rotor sometimes it will get swing, right. So, Tm and T will be there. Tm is the mechanical torque or mechanical output of the motor, and T is the electrical torque. So, mechanical torque we have T into omega, twisting force into omega. Omega is 2 pi n by 60, 2 pi is the circumferential displacement of that total overall area, right, or displacement, right, circumference 2 pi r, and n is the rotation, 2 pi n by 60 is the time taken, right, that is the angular velocity, displacement by time, right. So, don't confuse 2 pi n by 60 is there, sir, how it is n by 60, 2 by n by 60, because 2 pi is the displacement, time is 60, but n is there. See here, time is equal to time taken for one revolution, 60 by n, 60 seconds per n revolution. If suppose frequency is what, omega is equal to what, 2 pi f, right, f is equal to what, 1 by t. So, just to change that, we get it t is equal to 60 by n. So, just to substitute 2 pi n by 60, we get it, right. So, Tm is the resultant. This is a, just you consider this is a rotor, okay. So, this one is rotor, this part is rotor, okay, and this one is rotor and this one is stator. Stator slots will be present and the stator armature conductor. This circle is the rotor, that is stator armature conductor, right. So, Tm is the resultant shaft torque that tends to accelerate the rotor in the positive theta m direction of rotation as shown in the figure. So, this rotation, okay, positive, and under steady state operation generator Tm and Te are equal. I told you, right, if it is while calculating the problems, I mean while solving the problem, if suppose torque of the mechanical output of the motor is if it is how much Tm is 70 point something, definitely we will get I mean electrical torque, just you consider 75 point something, I mean 9, definitely mechanical torque also 75 point something will get it, only slight difference will be occurring, and finally we will get torque, the difference will get 0 because same we will get it, okay. In this case there is no acceleration or deacceleration of the rotor masses, and resultant constant speed is the synchronous speed. So, synchronous speed, constant speed, it's a the rotation is directly proportional to generation of output voltage. If it is generator, 3 output we are getting, right. So, that 3 output directly proportional to that rotation. If suppose rotation is not there, there is no generator voltage. So, it is directly proportional. If suppose rotation increases, that generation of electricity also, that frequency also increases, right. So, that is a concept, swing equation, and we have a rotor dynamic swing equation continuation. Theta m is equal to omega sm t plus delta m, and where omega sm is a synchronous speed, omega is equal to what, synchronous speed is what, ns is equal to 120 f by p, machine mechanical radians per second. Delta m is the angular displacement of the rotor. Angular displacement we get definitely 2 pi, right. In the mechanical radians from the synchronously rotating reference axis. So, axis must be there while rotating the synchronous generator. So, from the derivation 14.2 with respect to time t, or so first you differentiate, after that double differentiation. So, here why we are differentiating, why we are taking this one, imagination part will be there and one variable part will be there. So, with respect to time also, the rotation also varies, right? So this is a concept. Finally, we'll get equation as 14.3. We'll get j delta d square theta m by d square equal to ta minus tm minus t. Tm in the sense mechanical torque, T in the sense electrical torque, Newton meter, right? So this is a derivation. Just to go through once, definitely it becomes easy. And see here, I told you power is equal to what? Torque into angular velocity, right? So T into angular velocity. Mechanical power developed by the motor, T into omega. Electrical power developed by the motor, E2 into omega or EB into omega. So both are equally will get it, but some slight difference will be there. Finally, we will get J omega m is equal to, J is the inertia, omega m is the angular frequency or synchronous speed of this motor, d square delta m by dt square, Pm minus P, right? P is the exerting power and P is electrical power passing in this area. This one Pm is shaft output mechanical less rotational losses. So losses they neglected, right? Because we need to achieve electrical power is equal to mechanical power. Finally, we will get m is equal into d square delta m by d square, Pm minus P. Pm is the mechanical power, E is the P is the electrical output. So finally, by using kinetic energy, H is equal to what? Stored kinetic energy in megajoule synchronous speed by machine rating MVA, right? And we have our rotor dynamic and swing equations. Finally, 2h d square delta by dt square is equal to Pm minus Pe, right? Otherwise, h by 2f, right? No, h by 2 pi, right? No, because h by 5f, right? So 2h is there. 2h divided by omega is what? 2 pi f. So 2 get cancelled, you will get only h by 5f d square delta by dt square is equal to Pm minus Pe per unit value. This is a swing equation of synchronous generator or synchronous motor. Pm is the mechanical power minus electrical power output. Pm is equal to T into omega, P is equal to EB into IA or V2 into E2 into IA, we'll get it. So just to go through the equations and then definitely we'll be solving the problem. I'll be sending the notes of this one, so please refer and you'll get everything ideas, right? This is the overall equation, and so finally h by 5f, finally we'll get h by 5f d square delta by dt, phi is 180 into f, Pm minus P, and finally delta square is equal to omega minus omega s. So these are the equations we are going to use while solving the problems. Okay.